In this module, we're going to be looking at the view a gene analysis, which allows you to look at the expression of a single gene within a specific dataset. In this case, we're going to look at the neuroblastoma dataset consisting of 88 tumors and run on the U133P2, which is an Affymetrix expression array platform. So under select type of analysis, we're going to select view a gene, and we're going to look at the gene MYC-N as an example here. So simply type in MYC-N and click proceed. This being an expression array platform, you are given the option to look at multiple probes within the gene. However, for most cases, we're going to select the gene that has the highest average expression across all samples. There are some automated quality control systems in play, which will give you notifications, for instance, here that this specific probe aligns to the wrong strand of genome. So one should be cautious about using such probes. And regarding the adjustable settings, we're not going to adjust anything at this time, and that is discussed in the Adapting R2 module. Simply click Next. And here we are presented with what we call a y-y plot. So you have two y-axes, both showing the log2 expression of your gene of interest, and samples are ranked from the lowest expressing sample on the left to the highest expressing sample on the right. In this case, with a range ranging from just below 6 on the log2 scale to up to 13 on the log2 scale. So what you can see here is that not only are you presented with the expression values across all samples, but you are also presented with a number of tracks or sample annotations below the graph which correspond to that specific sample. For instance, here we are shown clinical data such as MYC-N amplifications within the tumor or the INSS stage of the tumor, and you can toggle over any of these blocks or sample annotations, and you can see those specific annotations that are visualized. One can also toggle over the point itself on the graph, and you can see which sample you were talking about, in this case ITCC0021, and all of the associated sample annotations with that sample. So what you can see here is that there is a subgroup of patients that have a higher expression of MYC-N, and that seems to be associated with, for instance, the samples that have MYC-N amplification down here. So the red are amplified and the green are non-amplified. But what you may want to know is, are there associations between MYC-N amplification and some of the other sample annotations which might not be easy to visualize in these tracks below the graph? So there are multiple ways of doing this, and the first example we're going to show you is using the CliniSnitch option, which is here on the left menu. So simply by clicking the MYC-N under CliniSnitch, we are then able to see how the expression of MYC-N varies across the different sample annotations available for this dataset. For example, in this case, we can see that in INSS or in the staging, there is a significant difference of MYC-N expression across the stages. So if we want to view how this looks, we can simply click View, and we are then presented with this data in a box plot in this case, where you can see that there is a significant difference upon an ANOVA test. So there, between groups, which in this case is stages of the disease, there is a difference of MYC-N expression. And in this case, you can see that there is a high expression of MYC-N within stage 4s. So that's one example of how you can look at a single gene expression across different sample annotations. One can also look at the CliniSnitch historic option, which in this case you click the execute it in the old way, and you are presented with it in with the analyses in a more tabular form, and you can see that then within each of these sample annotations, in this case the INSS stage, you have all of the sub comparisons that can be performed. So every stage against every other stage, and in this case you can see that the most significant one, which is highlighted here, is between stage 2 and stage 4. And you can again click on this and you are presented with it in a graphical form. And you can see that there is a statistically significantly higher expression of MYC-N in stage 4s compared to the stage 2s. So that was using the CliniSnitch option to view MIC-N and how it associates with tracks within your data. But you might want to be able to perform your own group separations using the single gene view in the graph itself. So at the top left, you can see that there's an icon here that says filter or adjust settings. So if you click that, it brings you to the part of the page that is adjustable settings for your graph. And this is located directly below the single gene view graph. So you can simply scroll down as well. So one option that you might want to adjust on this graph is that you can see here that we are viewing 5 different tracks at once, or 5 different sample annotations. And that might be a little bit messy for what you're trying to show for your graph. And you might only want to look at how does the expression of MIC-N, for instance, compare to MIC-N amplification. So we can simply select the tracks that we would like to visualize by clicking on track display selection, and then viewing which sample annotations or tracks are available within this data set. And you can see the 5 that are currently switched on. So if we simply want to look at MIC-N alone, or MIC-N amplification alone, we can simply click off the other ones and leave MIC-N amplification as the track that will be viewed, and click adjust settings. And now we are presented with the same YY plot that we had before. However, we have cleaned up the tracks a little bit below, and now we are only seeing the MIC-N amplification. And here you can clearly see that the high expressing MIC-N tumors are the same samples that have MIC-N amplifications, which you can toggle over to confirm. With the same graph, you might also want to see how the distribution of stages within these tumors is distributed. So this is done by coloring the samples, for example. So under color mode, you can select color by track, and then I want to color each of the sample based on its INSS stage. And simply click adjust settings. And here you can now see that each dot on the graph is colored based on the stage of the disease. And in this case, you can see that the stage 4, which are colored in red, are towards the right side of the graph, which also correspond with the MIC-N amplification. When we were looking at the CliniSnitch data, we were also able to view or separate the patients or samples into different groups, which can also be done using group separations here. So if we would, for instance, like to, instead of coloring the samples by stage, we would instead like to split up the graph by stage of the disease itself. You can simply click on group separations, and now we can select the graphical type as being a box plot instead of a Y plot, and simply click adjust settings. And now we are presented with a box plot where MIC-N has been, or where the samples have been split up according to stage, and you can clearly see here that you have a higher expression of MIC-N in the stage 4 tumors, and the associated p-value from an ANOVA test is visualized above. So those were some examples of ways that you can manipulate the graph itself to visualize the single gene of interest within your data set. There are also other analyses you can perform using these single gene analyses. So for that, we're going to return to the simple YY plot. So I'm going to turn off the group separations and leave this as the YY plot. And I am then going to return to default coloring and adjust settings, which will bring us back to the original plot that we had. So here again, we have samples listed from lowest expressing to highest expressing. And what we can see here is that sample ITCC0021 is the highest MIC-N expressor in the entire data set. And what you might want to know is what other genes are also highly expressed in this sample. And in order to perform such analysis, you can see here on the right, you have something called a sample overview. So in this case, we want to view sample ITCC0021, which is the highest expressing sample of MIC-N. And by clicking view, we have an option here to get the extremes for the ITCC0021. So by clicking next, we are going to be provided with a tabular form of the genes that are most highly expressed within that sample and the genes that are most lowly expressed within that sample. And again, by simply clicking on an individual gene, in this case the IGLL3P, you are then again provided with a YY plot, which clearly shows that this sample is the highest expressing sample of the IGLL3P as well. Say, for instance, that we would like to then use this figure in a publication. There is also an option within all charts, not only within the single gene view, that you can provide yourself with a vector-based graphic or SVG output, which will allow you to manipulate it in such programs as Illustrator or Photoshop. By simply turning on true and adjusting the settings, you will then have the same graph with an option to download a vector-based image as well, which you can simply right-click and save as, or by clicking on it, you are provided with the vector-based image.